Hi James, so I'm going to try and just explain this visually because I think there's a bit of a disconnect going on. So here is the Earth, we're looking top down on it, North Pole in the middle, rotates of course from west to east, excuse me, I had to think there for a second. So it's rotating this way, and for an observer, this is our observer here, this way is west, this way is east, okay? Here's the moon and the sun's rays are coming down like this, across the moon. And if we draw a line from the sort of the direction of the sun's rays through the middle of the moon and continue that down, then that will be the location of the centre of the moon's shadow. So there's the shadow location there. And here is our observer's position. So for this observer, the shadow is to their west. So 1 hour goes past and this person, this observer, moves 15 degrees because the Earth rotates 15 degrees per hour. So this is that's our position 1, that's our position 2. So now they're here. In that same period of time, the moon has moved 2,200 miles because it moves at orbits at 2,200 miles an hour. So it moves about, which is about its own diameter, so it moves to here. And drawing that new line down, that's now the location of the moon's shadow. So our observer started here with the moon's shadow to their west. They've finished here, having rotated along with the Earth, but the moon's shadow is now to their east. So the moon's shadow has moved from west to east. But as far as the apparent motion of the moon goes, it's this is not to scale, of course. The moon would be much, much further away. So you can't really get the angular rotation, depicted properly on this because it's wildly out of scale. But this observer would have started here, looking this way, and the moon is in the sky to their west, like that, this way. That's to the west of their zenith, and then here, the zenith is here, and the moon would look to be further to the west because of the rotation. So again, if that's again for the scale, you don't really get it, but that way, and then the moon is further to the west. So as that person's rotating and they get around here, then and the moon is again in its orbit a long, much further away, up here somewhere. Then the moon appears to be travelling from east to west, appears to be further to their west. But the shadow from the moon, because of the moon's orbital speed, which you can't ignore, appears to be moving across the Earth, or is moving across the Earth from west to east, despite the fact the moon appears to be moving from east to west because they are rotating with the Earth. I hope that kind of makes sense. It does work. It all maps out if you draw it to scale, and if you look at the geometry, that is how it works. You're obviously not getting it. That's fine. Please think about it and draw it yourself. And if you've got the capability, then draw it to scale.